ಕಾಣಿಸ್ತಾ ಆಯ್ತಾ ಸ್ಕ್ರೀನ್?
ಹ್ಮ್
ಒಂದು ಕ್ವಿಕ್ ರಿವಿಷನ್ ಮಾಡೋಣ. ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಏನ್ ನೋಡಿದ್ವಿ ಅಂದ್ರೆ ಕ್ವಿಕ್ ಪಾರ್ಟಿಷನ್ ಬಗ್ಗೆ ಕಲ್ತಿದ್ವಿ. ವಿ ಡೈರೆಕ್ಟ್ಲಿ ಮೆಂಟ್ ಟು ಮೇನ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಅರೇನ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ, ಮತ್ತೆ ಅನ್ಸಾರ್ಟೆಡ್ ಅರೇನ ಪ್ರಿಂಟ್ ಮಾಡಿದ್ವಿ. ಅದಾದ್ಮೇಲೆ ಕ್ವಿಕ್ ಸಾರ್ಟ್ ಫಂಕ್ಷನ್ ಅನ್ನು ಕಾಲ್ ಮಾಡಿದ್ವಿ, ಪಾಸಿಂಗ್ ಅರೇ ಮತ್ತೆ ಲೋ ಮತ್ತೆ ಹೈ ಆಸ್ n-1 ಈ ತರ ಪಾಸ್ ಮಾಡಿದ್ವಿ. ಕ್ವಿಕ್ ಸಾರ್ಟ್ ಅಲ್ಲಿ ಏನಿತ್ತು, ಇಫ್ ಲೋ ಈಕ್ವಲ್ಸ್ ಹೈ ಕಂಡೀಷನ್ ಇತ್ತು, ಮತ್ತೆ ಪಾರ್ಟಿಷನ್ ಇಂಡೆಕ್ಸ್ ಇತ್ತು. ಫಾರ್ ಪಾರ್ಟಿಷನ್ ಇಂಡೆಕ್ಸ್ we called a function called partition and we passed array low and high, and then we swapped some numbers in the partition so that our partition index left side ಎಲ್ಲ small elements pivot in the ಮತ್ತೆ right side all the greater elements, then we returned I plus 1 to partition index. Okay, after this, to sort the left elements, that is less than pivot, we called again, that is we recursively called quick sort again, passing array low and p minus 1. And to solve, that is to sort right side of the party pivot, what we did, we called quick sort passing array p plus 1 and high. You can imagine this as what, as a tree, as a branches of the tree. Okay, that is what this quick sort did. And this partition did that is divide. So basically what we are doing here, divide and conquer. Okay, that's it. After the sorting, we printed the sorted array. Okay, after that we checked what is linked list. There are two types of linked list, that is singly linked list. In singly linked list, what is a linked list? That is a data structure, not a data type. It's a data structure which contains singly linked list, contains data and a pointer. It has two things, that are data and a pointer. And where is the pointer pointing to? The pointer is pointing to our next node in the list. Okay, this is what one-way traversing, that is we cannot come back. Okay, after this we saw doubly linked list. What is doubly linked list? It is a data structure again, it is not a data type, which contains data and two pointers. Here what it contains? It contains a data and two pointers, that is the next pointer that is pointing to next node, and the previous pointer which is pointing to what, previous node. There are two-way traversing, that is we could go from we could traverse from head or we could traverse from tail, but this way traversing becomes more easy and efficient for us. Okay, after this we saw implementation of linked list. So what we did, we called main function, then we initialized the head pointer to null because our linked list was empty, so our head should be null. Okay, after that we called create node to head, passing an element in it, that is data. Call create node function which creates a new node. Okay, what does this do? It creates a new node with the by calling malloc function, which assign some space in the memory and point which returns the pointer. Okay, that is what is happening here. Then after this we traverse the list to our next node, that is our first node, and then we called create node again. Okay, here what we are doing, we are traversing it to the last element and assigning the value. Okay, after this we do 3 to 4 times, or how many, it depends on your size, or it depends on how many elements you want to insert in the list. You have to keep on traversing and you have to keep on adding. Okay, after that what we did, we displayed it. Before displaying, what we did, we took the pointer of the head variable as temp, as not as temp. We copied the pointer from head variable to temp variable. Now what temp is pointing to? Head. Okay, temp is pointing to head. And after that what we did, we traversed the temp. Okay, we traverse the temp pointer, so that when the temp is traversing, we keep on printing it. What we are printing? We are printing data. So what will it print? It will print the elements that are x1, x2, x, all of this. Okay, so this was quick revision, and today's topic is stack. Before this, I wanted to discuss about this memory pool allocation. So this is a 240, almost 250 line code, but there are lots of comments in between. Not comments, mm, a little bit space and all. Yeah, but this is a 250 line program, and to understand this program, what we need is we need we need to have the knowledge of space complexity. Then we need to have the knowledge of time complexity. Also, we need to have some knowledge of inbuilt functions like malloc and free. And most of all, we need to have knowledge of double pointers and how things are working. So, before going to this, what I thought is let's complete our data structures and then we'll get a better idea of how data structures work. So, after that, we could go to this program. So, this is a very advanced program to understand more about memory management in C. So what we are doing, instead of going traditionally by malloc and all, what we are doing, we are taking a special space in our RAM, and then we are managing the memory ourselves. So it becomes a little hard, but it is very efficient for us. See what happens is in malloc is our RAM. If our RAM is very big, then what does malloc do? It randomly allocates spaces, so that becomes very what inefficient. So that is why what we are doing, we're taking a large chunk of what space, and then we are managing it ourselves. Okay. So this program will understand this, but I think today is not the right time, or I guess after 1 week also, it's not the right time to understand this program. Once we complete our data structures, then after completing our big O notations, that is asymptotic notations and space complexity, this program will make more sense to understand. Okay, so that was about a quick recap. I hope you guys are with me. Hello?
Hello.
Yeah. Did you guys understand?
Yes.
So today's topic is stack. So what is a stack? What is a stack data structure? Let's see. A stack is a linear data structure that follows a last in, first out. That is LIFO principle. Okay. This means that the last element added to the stack is the first one to be removed. Okay. We don't want this. Let's go to images and let's see. Okay, this is it. Mm, It would be better if we have Geeks for Geeks. Yeah. So, what is a stack? You can imagine stack as this, a glass where you're inserting what different types of ice cream flavors. Getting my point?
Yes.
You can imagine stack as what an ice cream glass in which you're inserting different types of ice cream flavors. The first flavor you insert will be the last flavor you taste. That is what it is saying. See, what is it? What is the definition? Last in, first out, or we could also say this as first in, last out. So the last ice cream flavor which you will be inserting in the glass is the first flavor which you will be tasting. Getting my point? See, if you inserted this C flavor in the glass, then the first this flavor which you'll be tasting is this C flavor. Okay, fine. You'll empty the C flavor, then you'll come to the B flavor, and then you'll come to the A flavor. So, what is a stack? A stack is a data structure. What are all these C, B, A? They are all what data. So, what is this? It is a data structure which follows the principle of what? Last in and first out. Understand what is stack?
Yes.
So this was the basic definition of stack. Let's see if it's a linear data structure. What is it? It's a linear data structure. Means there is no There is no such thing as trees or different types of binary tree or something like that. It follows what? It follows linearity. It is a linear data structure. Okay. Then what we have here, and we can perform some operations on it like push, pop. We'll see it. Okay. This was the basic idea of stack. Let me recap you. So what is a stack? A stack is a data structure which follows the principle of last in, first out, or first in, last out. Okay, this was the basic definition of stack. Now let's move to our program. Yeah, uh, here let's take stack. Stack is what? Stack is a data structure. Okay, that does not mean that stack is different from arrays or stack is different from linked list. What we will do is we will implement stack using arrays, and we will implement stack using what? Linked lists also. Okay. What is stack? It is a data structure, not a data type. Okay. Understood.
Yes.
Now let's start with stack implementation in arrays. So what we did, we defined max, that is stack size, which equals 100, and we included our input output stream, we include our standard library, and we defined what a type defined struct with the name stack, array stack. Okay, which has two what two variables, one array type and int type, that is array max, and one is top. So array max is what? It's an array. Data max is array, and top is just another variable of type int. So so we defined here what? Type defined struct. After that, we'll directly move to our main array stack s. We are defining array stack. Uh, okay, then after that we are what? Initializing stack. Let's go to initialize function. We are initializing stack, and we are what? Passing the address of the stack. If you may see clearly, we are passing the address of the stack. Let's go to initialize stack. Where is it? Yeah, here it is. So what we are doing, we are initializing s, that is the top of s to what? -1. So why we are doing this? Because our stack is empty and there is no top element. Our stack is empty and there is no top element. Therefore, what we are doing, we are assigning the top value to -1, which says what? The stack is empty. Understand?
Hmm.
Hmm. So after that, what we'll do? We'll go here, and what we are doing? We are push. We are what? Pushing. Push. That is, we are passing address of x, address of s, and we are passing some data. Again, we are pushing. So let's push it one time and see what happens. We are calling the push function and passing what? We are passing the address of x, s, and we are passing some data. Let's go to push function. So what does push do in stack? Push add an element to the stack. So here what is push doing? It is adding an element to the stack. Where does this element go? It goes in the glass at the bottom of the glass. That is, it will be our first element. Okay, let's see. What we did, we passed the address of x. Okay, we received it and we received some value. Now, if s top equals max -1, so what is this saying? Let's say our max is what? Our max is 100. Then s dot top equals what? If s dot top, or we could write it like this only, top equals 99. What does this say? See,
Stack Overflow.
yeah, exactly. Stack Overflow. Why did it overflow? Because our stack is already full. We are using what? We are using a data, this array. What we are using array data structure. Therefore, we are predefined the size of it. So once the size is full, our stack will what? Overflow. That is what? If your glass of ice cream is filled and you're still adding flavors, what will happen? The ice cream will flow out of the glass. That is what is happening here. The elements are flowing outside the stack. Okay. So we are checking if the stack is full or not. And if it's full, then we are returning stack overflow. Okay. Understood.
Yes.
Huh. Now what we're doing, stack dot data plus plus s dot top. What is this? What is this? What does this sentence mean? What we are doing is we are um, incrementing incrementing top, that is top to top plus 1. Okay. And what we are storing in top plus 1? We are storing the value that is 10. Okay. Understanding what is happening over here?
Yes.
We are what? We are going to the data, and what does this mean? See, our top is what? Minus 1. Our data is what? It's an array. S dot data, and this what does this square brackets indicates? That is array. And what does this plus plus indicates? Plus plus s dot top. This is what? This is the index in
Increment.
which we are storing our value. Understand what is happening here now?
Yes.
So s dot data and plus plus s dot top. What we are storing in the top? We are storing the received value. What is that? We are storing 10 in what? Data of data of 0 equals 10. Okay,
Okay.
we could write it
Okay.
like this as um, like this to our for our better understanding, because we have a struct type. Therefore, okay, we could write it like this. So what is data of 0 hold? Why 0? See, before storing, what we are doing, we are incrementing it. Why we are incrementing? Because array starts from what index? Array starts from 0, and our top is minus 1. So we increment it to what? Plus plus, that is 0. Data of 0 equals value, and what we return 1. That is what? True. Okay.
Okay.
So what is basically happening is in push we are checking if the stack is overflowed, and then if it's not, we are pushing the value. Okay.
Okay.
So after this, we'll go to our main function again. We pushed what? S equals 10, and then we are pushing what? And then we are pushing 20, and then we are pushing 30. So how many elements are there in our stack now?
3.
10, 20, and look, before this, what we'll do, we'll push some more elements for our better understanding. We'll push 40, and we'll push 50 for our better understanding. Yeah, there's it. Now, how many elements are there in our stack?
5.
5 elements, that is 10, 20, 30, 40, and 50. Okay, let's display the elements. That is what we did. We displayed the elements. Let's write it over here. We displayed the elements. Now, what we are doing? We will pop. What we are doing? We are printing F and pop. What does this pop do? Let's go and find out. So, where is pop here? Yeah, here it is. Pop. And what we passed? We passed what? Address of X. Now, see here in pop, we are not passing any data that what we have to pop. We are not passing what we have to pop. Understand? See, in this In this image, let's say you have what this strawberry flavor. Okay, this is what strawberry flavor which is inserted at the bottom of your glass. Okay, and after that you have a butterscotch flavor which you inserted on top of strawberry flavor. Okay, and now you're saying that you want to eat the strawberry flavor first. How is that possible? You cannot. You have to first remove what? First, you have to remove the butterscotch flavor, and then you will get access to what? Strawberry flavor. Therefore, what? We do not pass any data while popping. The
Okay.
pop element will be always the top element. Understanding?
Okay.
This is what the flow of stack is. So, if this is this much complex, then why are we using this stack? It's in our daily life, when you do web browsing and all, the history is stored in the form of stack. Or when you do undo redo. So what does redo mean? The previous thing. That is what? It's following what? The stack principle. So it's in our everyday life. We have to just see the things in the programming way. Okay.
Okay.
So these are where stacks are used. It's used in what? It's used in that is what I said, web browsing, and it's used in undo redo functions, or if you could say a tab functions, like that. It's used almost in lot of the places. Okay. Now what we are doing, we are popping the element. So take a wild guess, which element will be popped from here?
50.
Yeah, that's it. Because 50 was added what recently? That is 50 was added last. And 50 is what? The top. 50 is the top element. Okay.
Yeah.
Yeah. Let's go to
Yes.
pop function and find out what is happening. If s dot top is less than 0. See, we are what? We are popping it, popping it, popping it, popping it. And in one stage, what happens when the stack becomes empty, we will get an error. So why is that error happening? Because our stack is empty. It is what? It is underflow, not overflow. It is underflow. Okay. See, if our top is less than 0, that is -1. If our top is -1, what does this say? This says our stack is empty. Okay. Understand?
Okay.
Huh. So, so we are checking the condition if stack is empty or not. And then what we are doing? We are returning s dot stack and s dot top minus minus. So what we are doing? What we are doing here?
Decrementing.
Yeah, exactly. Top equals or top minus 1, and we are printing it. Understand?
Okay.
So ultimately what happens? The data is deleted. So what will print here? Will print 50. And after this, will do what? Will peak. Now what is peak? Peak is what? Peak is same as pop. But what does peak do? We are just seeing it. See, I'll explain you from here. Now what happened is you have what? A strawberry flavor and you have a butterscotch flavor. And when you did pop, what happened is you ate the butterscotch flavor. Okay. But in peep, what is happening is you want to check what is the topmost flavor. So what you do, you peek. When you peek, what you see the butterscotch flavor. But have you eaten it or are you going to eat it? No, you're not going to eat it. You're just seeing it. You're taking what? You're taking the information. What is the information that you're peeping, that you're getting while peeping? That is what? We have a butterscotch flavor which is on top of our stack. Understand?
Yes.
So the element is not being deleted or it's not being eaten. It's being what? It's being just peeped and the information is what? Copied. Okay, getting my
Okay.
point. So let's go to what peak. Where is peak? Yeah, here it is. Now, what we're doing in peak, we are just checking the conditions, same as underflow. And if the stack is array, then we cannot peep it because the class will be empty. So what is stack? Stack is what? Empty. If 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 stack is empty, okay, then what we are doing, we are returning as dot top. See, we are not decrementing the top over here as we did here. Why? Because we just want to return what is on top. We don't want to delete it. Okay,
Okay.
understood what is happening over here now?
Yes.
So what all this is happening, how all this is happening dynamically, because we predefined the size of what, our array to 100. The size is 100, but once it reaches 100, the stack will be filled. Okay, so before the filling of the stack, this is all happening dynamically. And there are lot of, that is what we have 95 spaces which are empty. So we could fill it, we could use it, or we don't want to use it, then we could not just use it. So all this is what happening dynamically. Okay, now we
Okay.
understood what peak is. Once we pop, how many elements are left in our stack?
4.
Once we pop, there are 10, 20, 30, 40. Only 4 elements are there. And once we peep, what is the topmost element? That is 40.
40.
Yeah. After that, we'll display. Now here we displayed. Now what did we see? We see 10, 20, 30, 40, and 50 that are elements in the stack. And then after performing some operation, that is pop and peek, and then when we see again, now we don't have the top element that is 50 with us, but we have 40, that is the top element 40 with us, but because we only picked it. Okay, so this is our what understanding of stacks in arrays. Okay, let's try to run this program then. Yeah, a stack is what? Oh, I did not save this. Okay, let's save this and let's run this again. Yeah, this is it. We have how many elements with us? Our stack has 50, 40, 30, 20, and 10. Okay, the popped element is what? The popped element is 50. And what is it? After popping the element, how many are left? That is 40, 30, 20, and 10. So what will be our top element? It will be what? 40. Okay.
Okay.
And now when we print the stack again, what is our output? That is 40, 30, 20, and 10. So this was a very basic understanding of implementing stack in our programming. Okay.
Okay.
Now let's move to how stacks are implemented in linked list. Okay. So this is also the program which I'm seeing today only. Let's see. Let's try to understand this program. So what we're doing, we are including input output header file, and we are including library, and we are defining a struct node which has what? Which has a data and a node pointer next. So it is
Okay.
clear from here that this is what?
Linked list.
Yeah, exactly. And what type of linked list is this? It's a singly.
Singly linked list.
It's a singly linked list. Okay. Now here, uh, in arrays, what happened? We could directly access the top by giving the index. But here, what we have to do, we have to traverse and we have to keep a pointer always at the top. So what we are
Okay.
doing again, we are what initializing, we are declaring a pointer top, which will be pointing to the top element in any case. Okay.
Okay.
And then we are declaring the size of what? Of linked list. So we are using two struct we are using over here, or you could also call it a structure. So let's move to our main function. So from these two definition, it is clear that we are pointing a top pointer to the top element. We have declared the size, and what it's clear from here that this is a data structure of type linked list, that is singly linked list. Okay, let's move to our main function. Now what we are declaring linked stack s, and then what we are doing, we are initializing and passing what? Passing the address of x. Okay, let's go
Okay.
to initialize the stack. Let's go. Where is it? Yeah, here it is. Initializing stack. So once we pass the address, the pointer takes it, and s dot top. The top. What is this? This is a what? A pointer. Top is what? Now, top is not data type of what? Int. Now, top is a data type of pointer.
Okay.
Someone came or what? Someone joined or what? So, uh, int what? Void int stack linked list. Yeah, here we will. The top is what? Top is what? A pointer. And what we are uh, initializing it to? We are initializing it to null. You know why we are initializing it to null? Because our top pointer is pointing where? Towards nowhere. Because our stack is still empty. Understand?
Okay.
Therefore, we are pointing it to a null. Okay. Now, after that, what we'll do? We'll take the size, and what is our size now? 0. Because the stack is what? Empty. Understanding?
Okay. Okay. Okay.
Okay, so we initialize the stack and let's move back to our main function. Stack initialize, then we are pushing some elements, that is 40, 50, and 60. We are pushing these elements. Let's move to push function and let's see how this push function, very funny. How does this push function work in a linked list? So we pushed what? We pushed the address and we pushed the value and we received it here. Now node pointer temp. Now what we did here? We declared a temporary pointer which is pointing to what? Which is pointing to an empty address of size node. Understand? Now here we are calling malloc function which returns a pointer type. And that pointer type, we need it to be a node pointer type, and we are storing that pointer type in temp. Now where is temp pointing to? Temp is pointing to what? Temp is pointing to a address, or we could say a space in the memory which is just uh, given by malloc. Understand?
Yes.
So I hope now you are very much familiar with this malloc function. Okay, let's I'll just say the what does malloc do again quickly. Malloc what? It gives a space, empty space, and it returns the pointer. That's it.
Okay.
Huh. Now if what is this?
Not.
Negation of temp. That is what?
Uh,
It's a not a temp. That is what? If temp is what? Failed, then memory allocation failed. If temp is empty, that is if temp is false. So how is it that when a temp pointer receives, then temp will be having a pointer of some different value, or let's say some binary value or something. But if is a condition statement which only executes if the statement is true or false, then how is it that this if statement is taking some unknown input like 1, 2, 3, 4, or 4, 5, 6, 7, or anything which is stored in temp? See, I'll say uh, if 0, 0, then false, and in all other cases it's true. Understand?
Yes.
Now you understood. So why did I say this? Because temp is not having 0 or 1, or temp is not a Boolean value. But still we are using only temp for if statement. So why is that? Because if is a condition statement which executes if and only if 0 then false, in all other cases true. Okay, so if temp is what 0, that is nothing, or we could say null, then memory allocation will fail. That is, we print the statement memory allocation failed. And now what we are doing, we are temp dot data equals value. We are storing the value in the data, and for the next pointer, what we are doing s dot top. Understand what is happening here?
Yes.
Huh. After that, s dot top equals temp. Now here we are initializing the s dot top to what? Temp. And after that we are resizing it to size plus plus. So what is the size now?
1.
Yeah, that's it. And what is the value in the size? I mean, what is the data value? What we passed over here? It's
40.
40. Yeah, we passed 40. So now what does our stack have? Our stack has what? Our stack has data, that is 40, and next, which is pointing towards null. Understand?
Yes.
And our top is temp. Okay. After this, we'll go again to, now let's just remove this statement because this will call again and again to push. Now we pushed 40, then we'll push 50 and 60 and so on. Understand?
Yes.
Now in C, it becomes harder for us to implement stacks because we have to define all these functions and all. But in Java, what we can do is we can just write it as object dot push or object dot pop, and that will pop our element for us, or that will push our element for us. So in Java, what it is all predefined, or it is what the functions are what available in Java in the what library files. Like here, we have printf. So printf is what predefined function in our C program. We don't have to keep on writing what printf does. We just can use this printf directly on in any of our function. But before using this, we have to what? We have to include this input output header file. So the same way in Java, what we can do is we can use this stacks directly. That is, we could write it as stack.push or stack.pop. We could just define our stack, and we could insert some elements in our stack. And then we have to include the library. In Java, we do not say header files, we say the library. We have to include the library files, and then we can start using stack directly in Java. Understand?
Okay.
Okay, now let's display. So what will be display? 60, 50, and 40. Okay. Now, if printf uh, no, what not if we are just printing it. We are just printing what? We are printing the popped element. Now we'll go to pop function. Where is pop? Yeah, here it is. In pop, what we did, we passed the address of s. In pop, now we are checking whether, now here, what we are doing again, negation of s dot top. What does this mean? This means what? The stack is, the top is what? Pointing to what? Pointing to a valid, or is it pointing to null? Now, if it is valid, then it is true. But negation of this what gives? It gives us 0. That is what? Null. And if it is null, then we have to print stack underflow. Why underflow? Because our top is pointing to null, which which means what? Our stack is empty.
Empty.
Yeah,
Empty.
that's it. So we are checking whether there are elements in the stack or not. Understand?
Okay.
And then we are returning -1. What does this -1 say? It says what? It says 0, or it says empty. Okay, this doesn't really matter. You could use 0 also, you could use 1 also, you could use 0. You could use -1 also. So this is just because this is an int, or we could just use void also here. That doesn't make any difference. Okay. But yeah, we have to return the value. No, yeah, so we have to use return type value. We have to return int. That is why we are forced to use return type here -1. Okay, or we could use just void, or we could just print our pop function here itself, and we do not need to return it. Understand? Instead of printing it here and calling it, we could just call this pop function, and inside the pop function itself, we could just define this pop as void type, and we could just print it over here. But uh, we are returning the value. So yeah, let's go. Let's see what happens. Now node is a pointer type a pointer temp. Now the top pointer is initialized to temp pointer. Now where is temp pointing? To the top, and where is top pointing? To the top. Understand?
Okay.
So here what happened is we did not need to traverse, as in the earlier cases, to reach the topmost element. What we had to do, we had to traverse the linked list. Getting my point?
Okay.
But here, now top is already pointing to the top element, so we don't need to traverse it to the top. We just need to what? We just need to initialize a top pointer to our temp pointer, and then we could just remove our data in the temp pointer, and we could decrement the size. That is what is happening here.
Okay.
Yeah, but now because this is a linked list and this is not predefined like arrays, what we have to do, we have to delete the memory which we had been allocated by what? Malloc. Understand?
Okay.
Now, because we have to manage memory more efficiently, so what we do, we free. This is what free function. What does this do? It deallocates the memory. Understand?
Yes.
Yeah, it is deallocating the memory where temp is pointing. Now, if temp is pointing to top, then we just what? Will return the value and will decrease the size. And then where temp is pointing, we will just deallocate the memory there. Okay,
Okay.
understood. Now here what pop will return? Pop will return the value. What is a value? That is temp dot data. Where is temp pointing to? Temp is pointing to what? Top. And what is the
Top.
topmost element? That is 60. Understand? So what will this
Okay.
value return? It returns
60.
60. Yeah, exactly. So what does this return? It returns 60. Now after that, let's peek. Peek. What does this do? In our earlier case also we saw, in array stack also, peek does what? Peek only sees the element. That is,
She's
it
the
gets it gets the information. It do not delete, It do not perform any operation. It just what? It just like a copy statement. It just copies the top element and gives the user. Understand?
Okay.
Now here we are checking the same condition whether the stack is empty, and if it is empty then we'll just return -1, that is invalid. So the user will understand that our linked stack is empty. And then what we are doing, we are returning top, where top is pointing to, and we are returning the data at the top pointer. Understand?
Okay.
Now what is this? What is the data in the top pointer?
50.
Yeah, exactly. And after that, what we are doing? We are displaying our what values. So for our better understanding, let's push 50, then 60, 70. Okay, then let's remove these two statements. Yeah. Now let's save this and let's try to understand this better with our what compiler. Oh, here I did we need a data as linked list stack. Yeah. Now what does our stack contains? Our stack contains elements that are 70, 60, 50 and 40. Now if I popped an element, which element will pop from here? 70 will
7.
be popped. Okay. And then on top, what is the element which is at the top now? 60.
60.
Yeah. Now what does a stack contain again? 60, 50 and 40. So this was about stacks. Understand?
Okay.
Oh, someone is joining. Oh, फिर से. Let's say. So this was about what? About stacks. Let's take a quick recap. In stacks, what we did. What is a stack?
It is a linear data structure
Linear
that
data structure. Okay. That follows. That follows what?
LIFO principle.
LIFO. That is last in, first out, or first
First
in,
in,
last
last out.
out. Philo principle. First in, last out. Okay.
Okay.
Now, what we could do, we could implement, we can implement stacks in arrays or linked lists. This was about stacks. Understand? And some operations we use in stack are push, pop, then we use peek, and then what we use? Yeah, these are some basic functions which we use in stack. So that was it for today, I guess. Okay.
Okay.
Now we understood what? We understood arrays, we understood linked list, and we understood stacks. So I guess this week we'll finish our data structures, I guess. Let's see what happens. Okay. So this was it for today. We understood about stacks. And once all these data structures are finished, we'll take our time and we'll understand the asymptotic notations and and we'll understand our space complexity. And after that, let's move to big algorithms so that we could understand the algorithms more efficiently and more better. Okay, so that was it for today. Let's end this. Okay.